Okay, hello class. Weekly update 2. All right, so first things first, thank you so much for your work this week. It's quite a bit of improvement from last week. So first thing, thanks for submitting your work as a PDF file. I think everyone got it this time. Again, vital for us doing our work and grading and for the campus IT. Secondly, thank you for making a better effort at trying to convince Chloe and I that you're understanding an activity. And for the activities, almost every person chose to do the desk ornament rather than the bottle traces. And so I put some of my favorite ones in your samples and examples. So let's go ahead and take a look at that. So we are in folks in your class, table of contents, module 1, samples and examples. And so we're at week 2. So I dump a bunch in here. And you'll see sometimes I put like Sharika's in here twice for both her activities and her calculations. Same with Kendra, James, and Grant. And then I put some other folks, Calvin, Noah, Trip, Madeline, and David and Haley. They're desk ornament activities, I believe. Okay, and so again, most people chose the desk ornament, and I just want to show a few of those. So ones I liked were Kendra, Sharika, David, Haley, and James. And let's see. Let's take a look at Kendra's real quick. Whoops, actually it shows, this was Kendra's calculation one. So this was where you had to do those problems. She chose numbers 2 and 3. And what I really liked about this one in particular, so she breaks it down, shows the picture in R2. Remember, a contour map lives in R2. To be a contour map, you have to label your Z values. And then she graphs by hand over here. She tries to add the Z axis. She shows the breakdown Z equals K, solves for Y. She checks it with CalcPlot3D, which again, everyone, you should be doing this. This is a great way. You have access to these tools. No reason why you shouldn't check your work. You can check both the contour map with CalcPlot3D and then the R3 surface. So nice step-by-step there. Then let's go back to the samples and examples again. And week 2, let's take a look at Sharika's desk ornament. So what I liked about this was her description of her thought process, and then checking again with CalcPlot3D what that surface would look like, and the Z equals K labels. Now these might be a little off, 5, 10, and 15, but at least she knows that the Z axis is going up. The most common error I actually saw on this one was like some people had Z equals 1, 2, and 3, and that wouldn't make sense, right? These are heights, Z equals K. So as we go up the Z axis, they should be increasing. And then she also shows some work associated with this. So you didn't have to think about this one as a calculation problem, but it doesn't hurt to do that as well. Let's go back and look at, I really like James's as well. So I want to show the detail of James. I think this is his desk ornament. Okay, it's taking a moment to load, but it was a rather large file because James walks us through his thought process throughout. Like, here's the idea. He wants to estimate these K values. He shows a picture of what he knows this function must look like. He knows that the vertex has to be up here at 5. That was pretty easy, pointing down. And then he starts trying to estimate. So those other values have to be between 0 and 5. And again, this was the mistake some people made, right? These other Z equals K values have to range between 0 and 5. And he gives an estimate for what he thinks they might be, like 10/3, about 3.3, 2.5, and he thinks the other ones may be around 1.6. So those are his estimations, and then he shows here the picture. Again, a lot of you just showed that with your labels, but he's showing why he picked what he did and gave a lot of thought process showing he understands completely the function, and how these z equals k curves are connected. Okay, and again, this desk ornament one's a nice one. Hopefully keep it on your desk and it'll help you when you're studying later for the final exam. All these activities and assignments and challenge problems are meant to help prepare us for the final exam and to solidify these ideas in our brain, because we've physically interacted with them and we've built something, we've constructed and deconstructed things. And in this case, when you look at this, hopefully months later, the students tell me this after they finish the class, they did. Studying for the final is so easy because they just take one look at this and there's many concepts that go with it. They know, as he's shown here, it's on the XY plane, an R3 surface, you get the bird's eye view and project the intersection of the z equal k planes with the surface, and that creates this circle, and they get projected down into the XY plane, creating a contour map. These are horizontal planes, the z equals ones. This is an R3 surface. The intersection of those makes a circle, which lives in R2. That is a trace. Z equals k level curves, also called a trace. So lots of key terms that you can, just by looking at that, you can gather. Okay, then I want to go back to the calculations. Again, I think we looked at Kendra's. Lots of people did all four here, so I just wanted to give some shout outs for folks. You only had to do any two of the four. Calvin, James, Gavin, Aaron, Asher all did all four. So if you contact those people or take a look at their work, if you chose two and you weren't sure about these other two, take a look at your teammates' work, your classmates' work. Let's see, I really liked some more shout out to Noah, Isabella, Phoebe, and David. They had really methodical step-by-step process to draw the contour map. Grace and Tripp did very nice, concise, like they were able to fit it right there on that notebook page in your journal. Very concise, but everything was there that you needed. All right, let's take a look at a few though. I want to look at, let's see, I think Haley and James made the comment that number 3 was particularly hard to draw. They could see it, they're like, I can see it, but it's kind of hard to draw. And so I want to talk about, well, Kendra just said same thing. I think she did number 3 and used a tech tool to draw it, and that helped her do her drawing. She could check what she visually saw. Sometimes it's a matter of you see it, that's great, that's what we need, but you have to translate that into R2 paper, and that's a little bit of art skill. You'll get better, I promise, throughout the semester. But why not leverage off these tech tools that we have? And that's what Kendra did. And let's see, and then I want to point out another thing you could do is this is really clever. I hadn't thought of this, and I think I'm going to try to see if I can work it into future editions, Madeline. So this is another excellent example showing the thought process. So Madeline's talking through K level curves, drawing them in R2, usually no problem, but it was kind of difficult, she says, to figure out what this thing's going to look like. Oh, so here's what she did. She took a sticky note that she cut out that kind of represented it. And it's kind of hard to see from this angle, but she's got each level curve on there. It would help too if we had those labeled with their z equals values. And then she shows from this angle, like here she was picking them up to that height. So like on the paper, she has the z equals k values right down there. And then that very one is lifted up to this height and shows the angle. It's got this like wavy contour. So that's just a little section that she cut out. It makes it really easy to see. So again, number 3 was probably one that was toughest for folks. And her approach really helped visualize it. So be creative. All right, let's go back to one more. I really noted that I liked James. So let's take a look at James. I think this should be his calculation. He, like several other, Calvin, Gavin, Aaron, Asher, and James did all 4. So this is a way to check your work. This is a great resource. Again, showing the different level curves that he chose with the contour looks, and then how going to the 3D for each one. Again, very similar to what we just saw with Madeline's. And then the surface, he's like, this is my 3rd attempt to draw this. I can't get it to tilt the way I want, but I do see it. It's just the drawing. And again, that's kind of the step that can be tough, but if you see it, I'm more impressed than more concerned that you can see it, then I also want you to also say, hey, I can use a tech tool. And remember, that's what Kendra went to. Great resource to do that. Okay, so excellent work there. Remember, just a few things to highlight. A contour map always lives in the XY plane. It's a two-dimensional thing. You have to have your z equals k level curves labeled, or it's not complete. Put 3 to 5 of them on there till you get an idea. If you still are struggling, add a few more, and you'll get a more complete picture. You always want to make a range of those values. Try some positive, negative, 0. Sometimes they won't work for a particular problem. This one, you could try anything. There are no restrictions on the domain. Other ones, maybe, let's see. This one here, there's some restrictions, right? So James shows us z has to be greater than 0, so he couldn't pick 0 or negative values for z, but he could in some of these others. And the reason we do this, so the most common error I would say on the contour map was a lot of people just drew this. That's great if you're so good that you can just visualize, you can just kind of look at the surface, and I know there's a few of you that can, and just jump to this. But to get full credit in the final exam, you have to show your work and showing that you went from the R2 contour map to the R3 drawing. And of course, again, in the future, we can, for applied problems, yes, you can just use a tech tool and help you, but we want to make sure we understand why we're doing all this. And that'll become really important when we get to chapter 2, which we'll get to in a moment. Okay, so next thing I need to talk about, you had a lot of work this week, so great job on those. Let's go to your challenge problems. So I think I've saved a few of these. So almost every group but one chose challenge number 1, which was making the sculpture in the Museum of Math, and it does look like a penny race. So I think, yeah, every group except for 8 did that one. And I want to point out some shout outs for group 2, Phoebe, Lauren, and Asher. They did level ups 2 through 4. I really liked group 4. This is James and Max N. We got a couple of Maxes, so Max N. They really tried to understand what those transformations like ln does. What does the squaring do? What is the adding? And so theirs was a nice discussion. I think that one is here. Yeah. Okay, so a lot of their preliminary work before they even got to the final report was trying to understand what the ln action does here, right? So we wanted to understand what ln does. So they looked at what z equals ln x does, and you see by the end, right? I think I have a picture. Yes, right here's that ln action. So you do see that, and if it was an exponential action, we would expect, that kind of curve, right? So understanding the pieces of the puzzle, showing by hand what they did, then also with the tech tool. All right, next one I like was group 5. This is Calvin and Isabella. This was a really nice mix. If you look at their pre-work before they get to the final report, they included a ton of stuff here, right? This was their evolution of how they were going through the process. And let me just show you a couple images that I really like. So they're showing all their work, and it's a nice mix of by hand plus tech tool, right? So here's some tech tools. And by hand, here's their contour map, graph paper, then sort of add and then here was a nice drawing in R3 of each one of those level curves, and then linking them together in the next one to picture, some more images. And then that's all just their prep work through them going back and forth. It seemed like really nice teamwork on this one. They also did levels 2 and 3 in this, so they understood what, rather than having the circle, when you had like 2x squared plus y squared, that makes it an ellipse, and they pushed it. Okay, let's go to group 6. So try to keep, so I don't have you too long here for the issue of time. This is Noah, Connor, and David. One thing I really like on this one is, well, they did levels 2 through 4 as well. So I think it was clear that anytime you do a level up, those are bonus, they're optional. You get some bonus points. And you can do those as individuals or subgroups or the entire group. So just make sure you let us know who did which level up, if it's all 3 of you or just part of the group. And oh yes, so what I liked on this one, again, they did all the level ups. Please check that if you were interested but didn't have time. They saw what the +1 did. It just shifts everything up 1. They saw again what making it rather than a circle but an ellipse, so an elliptical. Oh, yeah, so one thing I want to note is they use LaTeX. So this is a great typesetting software. They prefer to write their equations that way, and then they just sort of screenshot it in, and it's a mix between LaTeX, some other tech tools that they screenshotted from, and CalcPlot 3D. Excellent job. Okay, I really like group 7. Shout out to Gavin, Grace, and Kyla, because it was just a very concise, clear report. It was straight and to the point, what you needed to do. Group 9, I think I have that one here. We'll come back to 8. Group 9, this was Jake, Chris, and Trip. They did all the level ups 2 through 5, and they made a nice summary table at the end of how the functions equals a ln of a x squared plus by squared changes, what happens in each of these cases. And we had some summaries with some excellent images. Okay, the only team to do challenge 2, which is the zipline one, was Haley, Kendra, and Wade. So congratulations on taking that one. And it was interesting why groups chose what they chose. And I just want to give you some advice. Throughout the semester, remember, these challenges are meant to teach you main concepts. And by going in depth in a problem, working with partners and discussing things, you'll start solidifying those concepts, and everything's getting us ready for that final exam. And so I started to see semester after semester, some groups would say, let's do, instead of challenge number 1, because I understand contour maps so well, or I understand topo maps so well, let's actually do number 2, because I don't understand little features of distance, or I don't understand vectors, or I don't understand topo maps as well. So often you can use that rather than making it, I'm going to choose it because it's easy and I think I'll ace it. I'm going to choose it because I'm not doing as well with that. And I think as a team, this will help us solidify some missing concepts. Okay, and so this one, just to show the groups, a lot of calculation work, but they needed to put a zip line through here that met certain conditions. And these are the 3 that they chose, numbers 2, 4, and 5. And then they had to show all their calculations to check that. And it doesn't show up as well in their screen capture here, but right, there's a topo map. And so making sure that you see the difference, like contour maps are topo maps and vice versa. You need to be able to go from a topo map to see the 3D image, or to see go from the contour map to see a 3D image. That's the same sort of thing. A topo map generally has a lot more detail, right, than a simple surface that we've been working with the contour map. So those 2 things are hand in hand. Make sure you didn't skip that and you understand the difference between topo maps and contour maps. Okay, and lots of calculations, so excellent job. All right, so just a few last minute things. The chapter 2 you're about to start, really exciting stuff. You're going to learn how to take derivatives in R3. So we'll learn a couple different types of derivatives, and they have so many practical uses. I think you're going to enjoy it. Also note that the MAA, the Mathematical Association of America, is very interested in this class, in your learning and what you're doing in journals. So they've made a quick little survey that will take this week. So when you have in your homework, it should take you 10 minutes or less to go through and do that survey. There'll be another one at the end, and they just want to assess this particular way of learning calculus. Okay, we'll have fun with chapter 2, and we'll catch up next week.